All right, equivalent statements and variations of the conditional statements. So an equivalent statement is a statement that is written differently but has the same truth value. Mathematically, we use a 3-lined equal sign, this guy, to show that two statements are equivalent. If a compound statement is true, then its equivalent statement is also true. It must also be true. If a compound statement is false, then its equivalent statement must also be false. Now, there are a lot of equivalent statements out there. We are only going to be concerned with the equivalent statement for conditional statements. And we're going to use these in the next section, which is arguments. So the conditional statement, if P then Q, can be written equivalently as not P or Q. So whatever you start with in terms of your P and your Q, you're going to negate the first term. You're going to change the if then to an or, and you're going to leave the third term alone. So if you started with not P, then not Q, the equivalent statement would be we negate P, so we make it just P, or, and then we leave the third term alone. We leave the not Q alone. So you negate the first term, you change the arrow to an or, and then you leave the last term alone. That's the equivalent statement. So you negate term 1, change the arrow to the disjunction sign, and then leave term 3 as is. So we're going to use this equivalent statement a lot when we get into our arguments. We also have variations on the conditional statement, different ways of wording the conditional statement. They don't always mean the same thing, but they're variations on it. So the first one we have is the converse. The converse of the statement if P then Q is if Q then P, so you just flip-flop them. The inverse is not P, then not Q, so you negate each term. Looking back at the original, which is if P then Q, you negate the P and the Q. The contrapositive of if P then Q is not Q, then not P. So you flip-flop them and you negate them. And then the biconditional is the biconditional. It is the P if and only if Q. So we're going to work through 2 examples on writing these out. And I don't know why it starts with example 4, but it does. So write the variation of the following statement. If the patient is not breathing, then the patient is dead. So the converse, we flip-flop them. So we say, well, actually, let's do something first. I'm sorry, I got ahead of myself. Let's identify the simple statements. So we have if the patient is not breathing. So the patient is not breathing. I have the word not in here. So I'm going to go ahead and call this not P. Then the patient is dead. Q. You could call this first statement P. It doesn't really change anything. Actually, I am just going to call it P. Let's just keep things simple. So the first statement is P, the second statement is Q. So So the converse says we're going to just flip-flop the order. So instead of P then Q, we're going to write Q then P. So as a statement, this is going to read, if the patient is dead, then the patient is not breathing. So I just flip-flopped where P and Q are. The inverse, I keep P and Q where they are, but I negate both of them. So if the patient is breathing, so I negate the first statement by not including the word not, then the patient is not dead. And I negate the second statement, Q, by inserting the word not. The contrapositive, I flip-flop P and Q and I negate them, or it's the flip-flop of the inverse. So it's if Q, then not if. If not Q, then not P. So if the patient is not dead, then the patient is breathing. And lastly, the biconditional, which is P if and only if Q. The patient is not breathing if and only if, which you can shorthand to IFF, if and only if the patient is dead. So 4 variations of the original statement that we started with. So there's another statement here. I encourage you at this point to pause the video and see if you can write out the converse, inverse, contrapositive, and biconditional on your own before continuing with the video. So if you are 17, that's going to be P. Then you are not eligible to vote, that's going to be Q. So the converse would be Q, then P. So if you are not eligible to vote, then you are 17. And this is one of those ones where it doesn't quite always work when we flip-flop them. But that's okay. We're still going to write them out. The inverse, not P, then not Q. If you are not 17, then you are eligible to vote. contrapositive, not Q, then not P. If you are eligible to vote, then you are not 17. That one does work. And lastly, our biconditional, P if and only if Q. Sorry, I was looking at what colors I had used. You are 17 if and only if you are not eligible to vote. And there we have it. Another example of the variations of the conditional statement.